Hello students, welcome to the session. Today's topic for the session is slopes of tangent and normal. We will discuss slopes of tangent and normal, and then we will discuss about maxima and minima too. Maxima and minima too in this session. Okay, so first we will start by our slopes. Slopes of tangent and normal. So let us start. So first of all, we should know what is a tangent, what is normal. So see, if we have a line like this and a curve, so it is your curve. See, the touching point, the point of contact is your tangent. So this is your tangent point. And see, if one line, if I draw perpendicular to this, if I draw a line perpendicular to this, just perpendicular straight line, and this will be your normal. So we have two lines from the curves, so it is your tangent. See how it is said to be tangent. See, tangent touches the curve at one point, so this is your point of contact. Let us suppose it is your P, and the coordinate of P is x1 y1. Okay, so the line touching the curve will be your tangent, and the line which is perpendicular, okay, which is perpendicular will be your normal. So perpendicular to the tangent is your normal. So this line is your normal. Okay, so now tangent is making an angle of xi. We will suppose that at this tangent is making a line, is making an angle of xi with the mid coordinate axis x-axis. Okay, it is basically your x-axis. So let's start. So we will see what is the slope of a tangent, then we will discuss slope of a normal. So slope of a tangent first. Slope of tangent. See, always you will be given a function in terms of y is equals to something. Y is equals to x square plus 2x plus 3x. Just like you will be given a function y in terms of x. Okay, and it should be a continuous function. Continuous. There should be no break. It should be a continuous function. Okay. Then the tangent, the slope of the tangent is your dy by dx. The slope of a tangent is dy by dx at point P, and you have the coordinate of P as x1 comma y1. Clear? So dy by dx at P x1 comma y1 is your slope of the tangent. Okay. And slope of the normal, what will be your slope of the normal? The slope of the normal will be, see, it is your tangent, it is making a slope. Similarly, it is a normal, it will be also making a slope. So slope of a normal is given by dx by dy at P. This is your slope of a normal. Okay, minus 1 upon, it will be your minus dx by dy at P is your slope of a normal. These two things you have to remember. So basically, whatever your function is given in terms of x, you have to differentiate with respect to x, and you have to find the tangent slope at the point which is intersecting, which is touching, point of contact. At the point of contact, if you put the values in dy by dx, you will get your slope of a tangent. And if you want the slope of a normal, then just reciprocal it dx by dy with minus sign, you will get your slope of a normal. This P indicating that you have to find the value at the point P of the curve. Okay, so let us see one example. Find the slopes. Find the slopes of the tangent. Oh, find the slopes of the tangent and the normal to the curve x square plus 3y plus y square equals 5 at 1, 1. So we have discussed the slope of a tangent and slope of a normal are the slope of a tangent is your dy by dx at the respective point. Let us say it is your p point, and slope of normal will be your minus dx by dy, let's say at p. So we will find this step by step. So this is your function given. So first we will differentiate this with respect to x. So now differentiating the given function with respect to x, both the side. So we will get 2x plus 3 dy by dx plus 2y dy by dx equals 0. So now club dy by dx term together. So 3 plus 2y dy by dx equals minus 2x. You will get your dy by dx as minus 2x upon 3 plus 2y. Okay. Now, now you have to find the slope of a tangent. So dy by dx is your slope of a tangent, but at the point, respective point. So it is your dy by dx at p, and p is your 1, 1 is your slope of a tangent. So we will put the value x equals to 1 and y is equals to 1. Minus 2 into 1 upon 3 plus 2 into 1 will be your minus 2 upon 5. So this is your dy by dx, and this is your slope of a tangent. Slope of a tangent. Now we will find the slope of normal, and slope of normal will be your dx by dy, okay, with negative sign. So at p is equals to 1, 1. So we will write this expression in reciprocal form with negative sign. So it is your minus 2 at x and 1. X and y is your 1, 1 value. So it is your 1. Okay, so we will write in reciprocal value with minus sign. So we will write as 3 plus 2 into 1 upon minus 2 into 1. So you will get answer as minus 5 upon minus 2. We will get our answer as 5 by 2. So this is our slope of a normal. So in this way we have to calculate the slopes of a tangent and normal, and at a particular point we have to follow this process. Okay. Now let's take another example. We have to find the slope of a tangent and normal. Second example, we have to find the slope of tangent and normal at point x is equals to 2. Okay, and the expression is here y is equals to x cube minus x. So first of all, we know our slope of a tangent. Slope of tangent is dy by dx, and slope of normal is minus dx by dy. Whatever point is mentioned, we have to put the values of that point. Okay, so here the expression is given y is a function of x. So what we will do here, dy by dx as 3x square minus 1. Okay, so only x equals to 2 is mentioned. So our slope of tangent at x equals to 2, that is your dy by dx at x equals to 2 will be your 3 2 square minus 1, that is 3 into 4 minus 1 will be your 11, and slope of normal at x equals to 2 will be your minus dx by dy at value x equals to 2 will be your minus of dx by dy means 1 upon 3x square minus 1 will be your minus 1 upon 3 4 minus 1 is your minus 1 upon 11. Okay, so slope of a tangent and slope of normal we have to find like this. Now we will discuss our next topic, that is maxima and minima. So maxima minima is very important, comes with a good weightage. in your boards, maxima and minima. So we will discuss maxima and minima, the first derivative test. Okay, we will discuss the first derivative test. So now for this we should have a function. A function should be differentiable. Okay, so what it say that f be a differentiable function defined on an interval I. Okay, there may be an interval, closed interval, open interval, maybe. Let A belongs to capital I. There will be a point A, it belongs to this interval. So now the method starts like this. First, the point this x equals to A will be your point of local max of f if at f dash A is equals to 0. Your first we will put our f dash A equals to 0, then we will get our value at A. If it shows a nature like this, f dash x is f dash x, see, if let us suppose your A is here, if f dash is becoming less than this side and f dash greater than 0 this side, then your A is your maximum point. Means if your graph should go like this, it is your maximum point. It is your maximum point. Here the function is decreasing, so we are representing as f dash x is less than 0. Here your function is increasing and we are representing as f dash x is greater than 0. So increasing and decreasing function is represented by first derivative f dash x less than 0 means your function is decreasing here. The function is decreasing here, and here the graph is going like this. Your function is increasing here. What is here? Your function is increasing here. Your function is increasing and your function this side is decreasing. Okay, your function is decreasing here. So your function is decreasing here. Okay, so function is increasing here. Clearly we can see that our function is increasing here and function is decreasing here. That this point, the maximum or the peak point will be your point of maximum. Similarly, we can say if your x is equals to A, at x equals to A, your x equals to A is a point of local minima of f if at f dash A is equals to 0. Again we will have that point A as a consideration. Now we can see that our graph from this to this, so this is your minimum point. Okay, so it is decreasing, now it is again increasing, it is decreasing, increase, and then it is increasing. So here your f dash x this side and here f dash x, the graph is increasing means your f dash x is increasing greater than 0. Your graph is decreasing means your f dash x is less than 0. So whatever the nature of the graph is showing beyond A, near A, so that will give you the local max and local min point. So if your A at your A nearby A, graph is increasing, then decreasing, you will get your max local max point, and around A, if your graph is decreasing, then suddenly increasing, you will get your minimum point. And the third case is also there. The third case says that there is no change. Okay, the third case says that if your f dash A is equals to 0, then you get a point A and there is no change. If here it is positive, it is positive. Again, if a is negative around a, the function is decreasing and decreasing. There is no change in the graph. There is no change. Then this point, that a point, in this case will be called local point of inflection. It will be x equals to a will be called point of inflection. Okay, clear? So let us clear this to a question and we can get good understanding about the concept. So find all the points of local max and minima of function f of x equals to x cube minus 6x square plus 9x minus 8. So here first step is always you have to let y is equals to x cube minus 6x square plus 9x minus 8. Then we will find your y is equals to this, or you can say it is your f of x. Initially it is your f of x. So we will differentiate dy by dx. What we will get your f dash x. F dash x means 3x square minus 12x plus 9. So always we will put this equation to 0 so that we can get our value of x. So we will put y dash f dash x equals to 0 or dy by dx equals 0. Now we have to solve this equation taking 3 common, x square minus 4x plus 3 equals 0. Okay, so your expression this will be 0. So we will be solving this equation. So we will get x minus 1 and x minus 3 equals to 0 into, so we will put this value and this value equal to 0. So we will get our x equals to 1 and x equals to 3. So we will plot these numbers on the number line. Okay, now we will check the nature. So what we will check? We will check the nature. Okay, so if after 3 we will check a point, let us say put a point 4. Okay, let us say let us think of a number beyond 4. So if we put this 4 in our f dash x, your f dash x is here. Consider f dash x is here. It is your simplest form. Okay, so put this 4, calculate in mind, but just check the sign, what sign it is giving. Okay, so we are getting positive. So this is your positive case. Now 1 to in between 1 and 3, let us think of a number. Let us think of a number 2. So we are getting negative sign, and less than 1 we have 0, famous 0 number. So we are getting 4. So see, your graph is changing from positive, then it is decreasing, then from decreasing it is increasing. So we will have our maxima at what point here? So function is increasing, then it start decreasing, then it start again increasing. In this interval it is increasing, in this interval it is increasing, like that. So at the point you will get at x equals to 1, you will get your point of max, local max, and at x equals to 3 you will get your point of minima. Okay, so you will get your point of local minimum, local maximum. We can write as local also. Okay, so in this way we have to calculate. So now let's check the other example, which was point of inflection. Okay, so we will see that through this question. If your f of x equals 4x cube minus 18x square plus 27x minus 7 has neither maxima nor minima. Okay, now see. So first step, let y is equals to f of x equals to 4x cube minus 18x square plus 27x minus 7. What we will do? Differentiate with respect to x. So this will be your y dash or dy by dx is equal to, now differentiate all this with respect to x. So we have 12x square minus 36x plus 27. Yeah. Now for the critical points, see, critical point means we have to put the value f dash x equals to 0. We will get our critical point, and this critical point should be plotted in the number line, and we will calculate the region. So why we are putting f dash equals to 0 to calculate the critical points. So now it is your 12x square minus 36x plus 27 equals 0. I calculated 4x square minus 9x minus 12x plus 9 equals 0. So you will get your 3. It is your 2x square, okay, minus twice of 2x into 3 plus 3 square equals 0. So on solving this, factorizing this, you will get your a square minus 2ab plus b square. It will be your a minus b whole square equals 0. So now you will get your critical point as, on putting this equals to 0, you will get 2x minus 3 equals to 0. Your x is equals to 3 by 2. Okay. So now we will plot this number on the number line. So we will get our 3 by 2 as like this. Now think of a number beyond this. It is 1.5. Let us say 2. Just we have to find the sign. We have to calculate the sign. So if we take a number 2 here, okay, so this is my simplest form of f dash x. Simplest form of f dash x, if I put here 2 value, so it will give you positive. Okay, no problem. So less than 1.5, let us suppose 1. If I put x equals to 1 here, 2 minus 3 is your minus 1 square is positive. See, we are getting our f dash x same. Here also positive, here also positive. So there is no change in the sign. That means the function is constant here. It is neither increasing nor decreasing. It is neither increasing nor decreasing. It is constant. It is not changing its sign. F dash x is not changing its sign. That means your x equals to 3 by 2 is your point of inflection. Your x equals to 3 by 2 is your point of inflection. So what is the point of inflection? Are you clear about this? The point at which there is no diversion in the function f dash x. That is, function is neither increasing there, neither decreasing there. It is not changing its root. So this is your point of inflection. So that's all for today's session. So keep practicing, and we will meet in the next session. If you have any doubt regarding the topics, you can contact me through my Urban Pro profile app. Thank you so much.